Light is one of those topics that people either throw their hands up and say, I don't know, when they're asked to explain something, or they come up with the wrong answer. I heard an explanation once of why the sky was blue was because the light was reflecting off the ocean. Horrors. Don't ever tell your students that. The sky is blue because the air molecules and the little water vapor molecules that are floating around up in the air scatter the blue light and absorb the other colors. That's why the sky's blue. What we want to do is investigate light, and there's areas that we already covered that you might want to review once again, like we did in heat. In the Earth Science series, there was astronomy when we saw how the sunlight shines on the Earth and creates shadows, and there's some good related activities on light in that section. And then earlier on this tape we talked about vision and how important our eye was as a sensor, something that detects light. What we want to do now is go on and look at characteristics of light, color, and intensity. And we want to look at sources of light. Where does light come from? Let's start there. The number one source, the most important source of light is, of course, our sun. And we're affected indirectly by sunlight. For example, plants need sunlight, and plants produce oxygen, which we breathe. And the plants die and turn into coal and oil, which we burn. So sunlight is very important for us. Then we have the artificial light that we can make, like chemical energy. We can take matches and light them in candles and burn the fuels, mix the fuels with oxygen. By a chemical combination, we can make our own light. We can put chemicals in batteries and then turn that energy into electrical energy, and in turn make light energy from the electrical energy. So we can do it that way. And we can take falling water and have it turn turbines to make light. There's many ways and many sources of light, and they should all be discussed with your students. Let's first investigate how well materials transmit light. Give your students samples of different materials. Give them some that don't transmit light very well, like this piece of cardboard. Other materials that are kind of in between, where the light goes through, but when you look through it, the objects don't look clear, they look fuzzy. These would be called translucent. And then finally some transparent materials, glass or plastic. And have them classify them into the three groups. You might even give them the words. Once they do that, have them go on and start to take a look at lenses and pull out those little magnifiers that you have in your classroom and talk about how a lens works, how it's taking light rays that are normally straight and making one bend in them. They don't curve, they go through to a different angle right away. And by being able to bend the light, we can magnify objects, make images larger. You can illustrate this, how a magnifier works, with a piece of wax paper over some newsprint. I've got some newsprint here, and you just get an eyedropper and put one drop of water on top of the newsprint over one of the letters, and let the students do this themselves and look at it, and they'll see that that letter is larger. They'll start to get the idea that it's got to be transparent and it has to have a rounded surface, usually outward, to make a magnifier work right. Then they can go on and take their magnifiers and look closely at different things like stamps. Very good activity. Lots of discovery involved in this. Then you want to talk about reflection and light bouncing. And the best way to do that is to use a rubber ball first and say that light behaves like a rubber ball. If it hits a nice smooth surface, it'll bounce or reflect. If it hits something like a carpet, it might go off in some strange direction and all the little particles go off in other directions, so it doesn't reflect real well. If the light comes directly down on the mirror and the mirror's flat, the light will bounce directly back up. If the light comes in at an angle and hits the mirror, it won't bounce back the way it came, but like a ball, it'll bounce off in the other way. And then give your students some mirrors and let them go out and have some fun with them, but warn them not to flash anybody in the eyes with them, and if they do, take their mirrors away from them. The best way to make mirrors like this so you can use in your class is to get those large mirror tiles, and don't be afraid of cutting your own mirrors up. It's not that hard at all. You get the mirror on a piece of flat bench, lay a ruler along the edge, and with a glass cutter just put medium pressure on it and run it along the edge of the ruler. Once you've done that, lay the cut edge, the line, right along the edge of the table and then just snap it, and the mirror will break right off. Watch. It's easy. Once you've got the mirrors cut, the final thing you want to do is get some black tape and run it along the edges so that your students won't cut their fingers when they're using it. Allow your students with their mirrors to go outside and experiment on their own for a while, flashing the image around, learning about reflection, how these angles come and go. And then set them down for a couple of games. First game, have them reflect the light off the sun onto a target that you put on the side of the school. Then we'll have what we call the mirror relay. This one's a lot of fun. Divide your class up into two teams, Team A and Team B. Within each team, the children line up in twos. You stand between two targets placed on the school wall. Place X's on the ground where the students will stand. Put a mirror on each X. The first pair on each team runs to the proper spot, picks up the mirror, and reflects the sun's rays from the sun between them and to the target. You're the judge. When you see light hit the target, tell the proper team. They put down their mirrors on the X's, then run back and tag the next two. Depending on the location of the sun and the positions on the ground, there may be many combinations for your class to try. Understanding shadows is not only good for understanding light and the properties of light, but it's also a very good vehicle for learning the scientific process and learning how to make investigations. When we look at shadows, there's 4 points that we should stress. First, that a shadow is formed whenever light hits a solid object. Second is that a shadow can change whenever the object moves or the light source moves. The shadow will move also. Third is that a shadow can change its shape if the object is turned or rotated, depending on the shape of the object. And lastly, a shadow is longer when the light source is low, and a shadow is shorter when the light source is high. There are many ways to illustrate these 4 points. Your students can make silhouettes of their faces on black construction paper and cut them out, and you can put them up around the room. And if it's early in the school year, it's even better because they can learn the names of their fellow students by trying to identify the mystery silhouette. Another thing is black out your classroom, pull the curtain, get out the slide projector or the overhead projector and put up the movie screen. You know the fun you can have with that. And if you want to be more creative, get a sheet and put it in the front of the room and illuminate it from behind. A student can go around behind the sheet and pick up an object that has a definite shape or a definite shadow and hold it up in front of the light, and the rest of the students in the class can try and guess what it is. You can even have more than one student go behind the sheet and make funny shapes like a man with 4 arms. Ask them how they might do that. Another thing you can do is get all the students in your class sitting in a circle and put one light bulb in the middle of the circle. Give them some objects that they can look at the shadows that they can use to experiment with, like this pencil, and I put a pin in the end of it. It allows me to rotate the pencil without touching it. It appears that the pencil is almost floating in air when I'm looking at the shadow. Another good thing you might try is a popsicle stick with a washer on the end of it. That'll give some really interesting shadows when it's turned and rotated, or even a paper towel tube. Now another thing you want to go an extension of this is raise your light up and lower your light down and let the students predict and observe what happens to their shadows when the light moves higher in the sky. And then take them outside and let them make observations early in the morning and around lunchtime so they can see how the shadows really do change, just like the model that you showed them in the classroom. Another thing while they're outside is have a student stand on the blacktop and let another one outline a shadow with a piece of chalk, or do it on butcher paper, and it can be cut out and put in the classroom again. There's a product out called solar graphic paper. It's not only excellent for experiments on light, but it's inexpensive. It's a packet of light-sensitive paper, and it comes in this black pouch. You don't want to pull it out till you're ready to use it. If you could have a sheet for every 2 students or even every 1 student, it would be great. Take them outside, give them some objects that they're going to find the shadows of, record the shadows. Like, let's say we're using this fork. Then when they're already out in the sun and ready to go, pull the piece of paper out and hand it to them. They put it blue side up, they set it down on a hard surface and set their object on it. If the sun's directly overhead or up high in the sky, you're going to get nice, clean, even shadows. If the sun is low, you get longer shadows and it'll actually distort the picture. After about 2 minutes, you'll notice it start to turn a paler color. It's time to develop it. Take the object off, take the paper back into the classroom, and just put it in a tray of water. In about 1 minute it'll be developed. Then you let it dry. You'll end up with some really interesting and fun shadow graphics like this. Now you ask the students, what does this mean? Why is it whiter here than it is here or up in here? And maybe they'll start to realize that the part that was actually touching the paper was the part that blocked the most light. A little bit of light got around the other side. So there's really a lot of extensions you can do with this. And if your shadows are low, look at what we have here. This key almost looks three-dimensional. And this, of course, if you can't figure it out by now, is a hole punch. We can also use this paper to investigate colors. Start by handing out some different sized and different colored plastic squares to your students. Have them look through them and describe what they see. And then ask them what they think will happen when these colored squares are placed on a piece of solarographic paper and then exposed to sunlight. After you get their guesses, go on and do the experiment. And I didn't know what would happen until I tried it, and I found some very interesting results. It appears that the green and the red one block out most of the light, and the blue one allows the light to go through. And I set this safety pin down here at the bottom so I could remember what it does when it blocks the light. So the head of the safety pin here is white. So I know that that blocks light, so these two must also block light. Now what have we found by doing this experiment? That's a good question to ask your students because it really gets them to think here. We've found that this paper is sensitive to blue light and not very sensitive at all to red and green light. We're starting to understand a little bit about colors and that some things are sensitive to certain colors, like our eye. For example, there's certain colors that we can't see that only bees can see in the ultraviolet range. So what we want to do now, after an introduction to colors, we want to go on and reinforce these ideas with more exciting activities. If you were an artist and could only pick 3 colors, which ones would you choose? Well, if you were smart, you'd take red, blue, and yellow, because these are the primary colors. And by mixing different combinations of these 3 colors, you can make many more colors. If you were allowed to use white and black also, you could pick up all the tints with the white and all the shades with the black. How does this work? Well, let's take a look at this color wheel, and you should probably have your students make one of these. You can really understand it with this. This color wheel has 12 blanks on it. I would have the students go ahead and color in 6 of the 12 as you see here. We see first our primary colors, red, blue, and yellow. What happens if we mix any 2 combinations of these colors? Well, red and blue make purple, for example, and blue and yellow make green. Let's test this with an experiment, and one that's easy to set up. Each student group gets 3 containers of stock solutions, red, blue, and yellow, and you can make them with just a couple drops of food coloring in each. They also get a number of small vials, about 4 of these, and you can get these at a science supply house, and an eyedropper. What we want to test is mixing the primary colors to make the secondary colors. Well, let's see, 2 squirts of blue in our vial, and then we want to add to it 2 squirts of yellow. But we don't want to contaminate the yellow with anything that might still be left in this eyedropper, so talk to your students about contaminating stock solutions. We don't want to do that. So we'll rinse the eyedropper out in a little cup of water first. Then we'll add our 2 squirts of yellow. We should get, according to our chart, green. So there's 1 and there's 2, and sure enough we get a very brilliant, beautiful green when we mix these 2. Now we see how these colors fall into the chart. What about these empty spaces? Now we're talking about more experiments. Say we took green and yellow, what type of color would we get here? Well, we have 4 droppers in this to make this green, so we need to add an equal amount of yellow. So we need to add 4 yellows in here to really decide what type of color we're going to get. And after your students do these and run these experiments through, mix them up, shake them just a little bit, and look at the color. And what they want to do next is hunt for the crayon that matches that color, and then go on and color in that particular box. They can do it for all the missing boxes, and it turns out to be a very interesting experiment. Now, mixing different colored paints gives us different results than we would get if we mix different colored lights. For example, if we mix blue and yellow paint, we get green. But if we mix blue and yellow lights together, we'll get a white light. So the primary colors in light are different than the primary colors are in paints. In paints we had red, blue, and yellow, and in light we have red, blue, but instead of yellow we now have green. Let's go on and investigate this in an interesting experiment. Save your 6-pack rings because you can cut them across and make little eyeglasses out of them. Here's how you do it. Cut them up and then get your students to get report covers of different colors and cut the same shape as the little rings, and then just staple them on. Then you get some yarn or string and tie it across so it'll secure behind the student's head. Now, in this experiment, you need at least 3 people in a group. You need one to wear a particular color of filter. You need another to hold up different pieces of construction paper to see what the first student will see when he's looking through the filter. And you need a third student to record the results. After one student's looked at all the paper through the green filter, then another student looks at it the same paper through the blue filter, and the third student gets to use the red filter. You're going to need a lab sheet that's going to have the color of the construction paper going down and the color of the lenses going across so they can write in the colors they see. There's some interesting results from this. For example, look at this sheet under white light. We see green and we see red. But if we looked at it through a green filter, what would we see? Well, watch, let me show you what it looks like. The red dot in the center reflects only red light, and the green filter will transmit only green light. Since these two are complementary colors or opposite each other, there's absolutely no light that comes through, so it appears to look black. The fun part of this experiment is when your principal walks in and all your students are working away, and he looks around and he sees all these people dressed up like this, with these strange looking space goggles on. And if you can get your whole class together, put them all on and get a group photo, send one to me.